Welcome back for part 2 of Chapter 1, Section 7, Understanding Rates and Unit Rates. Now it is your turn. You guys take and pause the recording, work this problem. Be sure to give some really good high quality supporting work, just like the supporting work I was showing you earlier, to come up with a good answer to go here. Check your answer and see what you get. Alright, did you get it done? The problem tells us that Samantha picked 45 oranges in 5 minutes, and it wants to know what the unit rate is. In other words, how many oranges can she pick in 1 minute? So to work that problem, we're going to take and set it up where we're going to have 45 over 5, where your top number is going to be your oranges. Your bottom number is going to be your minutes. And that, of course, is going to equal to some number of oranges. We'll call that x over 1 minute. Now we have set this up using equivalent ratios, and we need to figure out what we have to do to 5 to get it equal to 1. That is, of course, going to be divided by 5. So I have 5 divided by 5 is equal to 1, and that's the 5 and the 1 I have here. So therefore, to find my x value, I'm going to take 45, divide it by 5, and that is going to equal to 9. Therefore, the x is equal to 9 in my final answer. This is your supporting work. This is what I must see. If I see anything else, you will, of course, have done it just for fun. Check my answer, plug 9 in, hit the check answer slide, and we are good. Moving on to resource number 6. Now this one is really where the rubber meets the road. This is where you have a good, solid, real-world use of this type of problem, where you're comparing the unit price of 2 different containers to find out which one is going to be the better deal. A grocery store sells a 6-ounce container of yogurt for 78 cents. The store also sells a 32-ounce container of the same yogurt for $3.84. To determine which is a better buy per ounce, you have to find the unit rate of each item. The unit price is the cost per unit of the item. So unit price is a unit rate involving money. You can use what you know about unit rates to find a unit price. So the first one, you have the 6-ounce container for 78 cents, and they divided top and bottom by 6, which ended up telling them it was 13 cents per ounce. And the second one, you have the 32-ounce container for $3.84. They divided top and bottom by 32, finding that it costs 12 cents per ounce. That means that the 32-ounce yogurt is going to be the better buy. It is less, the unit price is less than the price of the 6-ounce container. Now the talk about it does ask a really good question. When might it be a better buy to buy the 6-ounce container instead of the 32-ounce container? That's a really good question. I mean, if the 32-ounce container is cheaper per ounce than the 6-ounce container, when would it be a better deal to get the 6-ounce container? Think about that one. Here's the answer. What if you don't need 32 ounces of yogurt? Alright, that's an awful lot of yucky yogurt. I know some people like yogurt. My wife likes yogurt. I hate yogurt. Alright, that's still an awful lot of yogurt. If you only need 6 ounces of yogurt, then buying 32 ounces is going to be a complete waste. You're going to be spending more money on yogurt you're not going to use. Moving on to our next resource. As I read my word problems, I like to highlight things that I think are going to be important. For Carolina's birthday, her mother took her, that's going to be Carolina, and her 4 friends. So her and her 4 friends combined is going to equal to how many people? Equal to a total of 5. To the water park, Carolina's mom can either pay $130 for a 5-pack, that sounds important, or $28 each for individual student tickets. What ticket price has the lesser unit rate? How can you compare the two prices? Well, we could compare equivalent ratios, or we could use the ratio table that they have set up here. You pause the recording, work it out, make sure you give me good high quality supporting work, and then I'll show you what I get in a moment. Alright, so we have a ratio table here that we're going to work backwards from. Now, we need to find the unit price, which is the price of one ticket. So I'm going to make that bigger and go back over to this slide. And on this slide, I'm going to write in my goal, which is one ticket. And then I have to ask myself, what do I have to do to 5 to get it equal to 1? Well, the answer is going to be to divide by 5. And if I do it on the bottom, I have to do it on the top. Divide by 5 on the top. All that one is not going to be quite so easy. So I'm going to do my scratch work off to the side. Dividing by 5. 5 goes into 1 0 times. 5 goes into 13 2 times, which is 10, with 3 left over, and the 0 comes down. 5 goes into 36 times, and 6 times 5 is 30, with nothing left over. So what's the answer going to be here? It's going to be 26. It's $26 for one ticket, which we can take and program in here. $26 for one ticket. Check our answer and check. Everything looks good. So that's going to be the cheaper option to buy the 5-pack instead of buying 5 individual tickets. It looks like that check isn't going to work, so we'll go ahead and hit our next resource button. But I do want to go back and point out, what do you see there? You see good, high-quality supporting work justifying your answers. You need to make sure you are giving me the same good, high-quality supporting work where I had my ratio table. I showed how I was going from 130 to 26 and from 5 to 1, and I showed my grunt work justifying my answers. You can't just throw numbers in without having supporting work to justify it. So, here we go. We're on resource number 8 of 10. At a grocery store, you can buy 4 cans of chicken noodle soup for $4.99 or 6 cans for $7.25. Explain which explanation is correct when comparing the unit price. Pause the recording, read through them, select your answer and check it, and then I will be there to follow up with you. Now notice you do have a need help section. If you want, you can take and read that. If you don't want, well, that's just fine too. We'll go ahead and work it and we'll see what you get. Alright, did you get an answer? Let's see what I come up with. I've laid out my 2 ratio tables here so I can work them out. Now the first one I'm going to have to get down, of course, to 1. Let me make my blue a little bit bigger there. I'm going to have to make that down to 1 can. So I'm going to divide the top and the bottom by 4. And so I have the same thing this way. I'm going to divide that by 4 as well. And I'm going to come off to the side and do my grunt work. 4.99 divided by 4. 4 goes into 4 once. Your decimal goes up. That's 4 times 1 is 4 with nothing left over. Bring down your 9. 4 goes into 9 2 times, which is 8. That's going to be 1 left over. Bring down your other 9. 4 goes into 19. That's going to be 4 times, which is going to be 16. 3 left over. And there we're going to annex in a 0 and bring it down. 4 is going to go into 30. 7 times. And 7 times 4 is 28, and we can annex in 1 more 0 and bring that down because we had 2 left over, and 4 will go into 25 times, which is 20 with nothing left over. That means this one is 1.2475. Now I know this actually that would round to $1.25 a can, but when you're buying multiple cans, sometimes it's important to carry a decimal place or two. We're going to do the same thing over here with the 6 cans. This time, let's make my arrow a little bit bigger here. We're going to take and divide by 6. Oops, put that in the wrong spot. Divide by 6 to get to 1. I'm going to do the same thing on the top here, dividing by 6. And I'm going to show my grunt work off right here. $7.25 divided by 6. Well, 6 goes into 7 one time. 1 times 6 is 6 with 1 left over. Bring down your 2. 6 goes into 12 2 times, which is 12 with nothing left over. Bring down your 5. 6 goes into 5 0 times, and at that point we can actually stop. We could take it another step if you want to round to the nearest penny. So let's go ahead and take a look if we were to do that. That means that 0 times 6 is 0. Annex in another 0 and bring it down. 6 would go into 58 times, which would have been 48. That means that this one would have been about $1.21. And I could stop it there because I can see there's a big difference. I've got $1 rounded to the nearest penny and 25 cents on the left, $1.21 on the right. That means that which one's going to be the better deal? The 6 cans at $1.21. From here we need to look at our options and see what we have. Option A, $4.99 is a better buy because, man, we know it's not the better buy, so we can get rid of that one. The $7.25 is a better buy because it has a unit cost of $1.21 per can, which is less than the unit cost for 4 cans. That one looks good. What are our other options? If the 4 cans is a better buy, that's not good. And then the 6 cans is a better buy because it had a unit cost of $1.24. Nope, that's not what we want. That's not the correct answer either. It had a unit cost of $1.21. So we're going to go back to our question, plug answer B in, check our answer, and we did good again. We are down to 2 resources now. This one's going to be an apply, so that's something you get to do. The Martinez family and the Davidson family each drove at a constant rate. The Martinez family drove 260 miles for 4 hours. The Davidson family traveled 305 miles for 5 hours. Which family is traveling at a faster rate and how much faster? Did you catch that? You actually have 2 questions. You've got to be able to answer it. But whoops, not sure why that jumped up there. The first question is right here. Which family is traveling at a faster rate? The second question is right here where they want to know, all right, how much faster are they traveling at? That means your final answer has to have 2 questions. You pause the recording and work through this problem to give you a little bit of a leg up. Right here, ask yourself first, without calculating, who do you think is going to be the fastest? Explain your reasoning. Yeah, you can do that if you want. We can look at that problem again. I'm just thinking, just a roughness, 460 and 3, 5. I'm personally thinking that the 5 hours is closer because it seems like it's going to be faster because it seems like they're going further distances in a lesser time overall. But we'll have to actually do some math to find that out. And then finally, you work through the problem, check your answer, see what you end up getting for that one. Well, I just realized that you couldn't actually check your work, but that's okay. Let's see what we have going here anyhow. First, we're going to calculate the Martinez family. So my Martinez family, I'm going to use my green marker. So for that one, I've got 260 miles in 4 hours is equal to some unknown number of miles, and we're going to call that M for Martinez, in 1 hour. From there I can say, well, what do I have to do to 4 to get to 1? I'm dividing it by 4, because 4 divided by 4 is equal to 1. If I do it on the bottom, I have to do it on the top, and 260 divided by 4, that is going to equal to, let's see, we're going to have 65, I believe, if I did that one right. Let me check it. All right, that was correct. So my answer for the Martinez family is that they were traveling 65 miles in 1 hour, also known as 65 miles per hour. Next, we're going to change colors to blue to find out the Davidson family, who did 305 hours in 5 hours. if we have 5 miles in 5 hours. So I'm set up a set of equivalent ratios here. 305 is to 5, as the Davidson family D is to 1. To get from 5 to 1, I have to take and divide by 5. 5 divided by 5 is equal to 1. Therefore, I'm going to divide the 305 by 5. And when I do that, I'm going to get, that one's going to require, let's see, actually 61 miles per hour. When I did that one in my head, which I'm pretty solid on that answer. So my Davidson's family is actually traveling at a slower rate of speed of 61 miles per hour. But what did the question actually ask? It said A, which family is traveling at a faster rate? So for that one, we would say that the Martinez family is traveling faster, is the fastest. And that's for question number 1. And then question number 2, how much faster? Well, that's going to be 65 minus 61, which is a difference of 4 miles per hour. This is the answer to your 2 questions. All right, we are on resource number 10. This is for you to do. Solve it. You have 2 questions to answer. If you need help, you can click on the need help box, check your answer, and then I'll show you what I did when I'm all done. Pause the recording while you work on it. Alright, here's my supporting work. You can download 15 songs from the Music Emporium at $12, and at Music Now you can download 10 songs from $9. What store has the lowest cost per song, and how much less is that cost? 2 questions to work with. So the first thing I'm going to do is set up my equivalent ratios. I'm going to say, we'll get my pen going here. First off, for the Music Emporium, I've got 15 songs for $12. So that's going to be $12 for 15 songs is equal to, and we will call this one E for the Emporium. Actually, nope. Yep, some unknown number of dollars for 1 song. And the other problem I'm going to set up is going to be for Music Now. And at Music Now, we get 10 songs for $9. So I say 10 songs for $9. Oop, I think I set that one wrong. I did set that one up wrong. They set us up for failure there, laying it backwards. The money goes on top. The number of songs go on the bottom is equal to, and we'll call this M for Music Now, over 1 song. From here, we're going to take and solve both of those. It's going to take a little bit of grunt work, and since it's the last problem, let's play with Satan on this one. So we're going to take and divide the first one by 15. 15 divided by 15 gave me 1, and that means that I would have 12 divided by 15, which is going to give me 80 cents per song. So for this one, whoop, got my color wrong there. For this one, the Music Emporium, each song is going to cost 80 cents or $0.8. Next one, for Music Now, you would have had to divide top and bottom by 10. So when I did that one, that means I would have had 90 divided by 10, excuse me, 9 divided by 10 to get to it. And when I did that, I would have got 0.90 for the Music Emporium. So the answer, who has the lowest cost? I'm sorry, that's for Music Now. The Emporium has the lowest cost, and how much less is it? 10 cents less. So let's go back and plug in our answers. We have the Music Emporium, isn't that the one I said? Yep, Music Emporium is less. And how much is it? 0.10. Check our answer, and both of them are correct. Get started on your homework assignments. Remember to give me some really good high quality supporting work as you do these so that I can give you credit for them. Have a great night.